polynomial cannot have any more real zeros than its what? What correlates how many roots it has to its exponent's degree? Yeah. Okay. All right. So for like this is the highest degree. So my highest degree of this one is 4. So therefore, I can't have any more roots than 4. Okay. All right, today we're going to talk about 2 different theorems. Okay, Descartes' rule of signs, which gives you a hint as far as what you're looking for when you're looking for your roots. And these are the actual theorems. And basically what it says is that if you analyze the f of x and look at the number of variations in the sign of the non-zero coefficients, all right, then you're going to have the roots of that, possible roots of an even integer of that less 2. So what that really means is if you look at our f of x here, you don't have to, what am I trying to say? You don't have to do anything because it's a regular f of x. And look at your coefficients. So I have a positive 3, I have a negative 4, I have a positive 3, I have a positive 2, and I have a negative 1. And you only do it with the coefficients. Okay? Then you take a look at and say, okay, I have 1, 2, 3 positives. So my possible roots of, or I should say of positive roots, okay, are either I'm going to have 3 positive or I'm going to have 1 positive. You always go down by 2. Better?
Wait, where'd you get the
-1.
one?
Yeah. Okay. All right. Now to find your negative. This is this typo. To find your negative real zeros, you put a negative x in for your function. So a -6 is still going to be the same sign, right? So that's going to give me a +3. X to the 4th, negative x, because it'd be like saying 3 negative x 6 minus 4 negative x to the 4th. That's still going to give me a +4. And then +3 negative x cubed, that's going to give me a negative x. So that becomes a -3.
That 4 changed, didn't it? From the top?
That's going to be, oh, that is negative there. Sorry, I can't read my own handwriting. My bad.
Oh, no, I was talking about the first. Maybe it was -4 and then +4, right?
No, because negative x to the 4th is going to give me a positive x.
Okay.
So it's the sign stays the same. Basically, if you have an even exponent, it stays the same. If you have an odd exponent, it's going to flip sign. All right, and then I have +2 negative x squared, so that's going to give me a +2. And then I have a negative x, that's going to give me a +1. Okay, so you look at the number of variations And again, I'm going 3 positives. You always take the highest one. So the possible negative roots are either 3 or 1.
So just take the highest one.
Yeah.
Subtract it.
Yeah. Yeah. And since this is an exponent of 6, my guess is that it seems logical, I'm going to have 3 positives and I'm going to have 3 negatives, because then that gives me the 6. That makes sense? Okay, that's the rule of signs. That does get helpful for when we're using the rational zeros theorem. Oops. Do you guys see my new melting? The elf has joined us. He doesn't work as well as the witch, but we need to break him in. So, anyway. Okay. Rational zeros theorem. This is the one. It's good, it's worthwhile, but it's putsy. Alright? Everybody know what putsy means, right? Takes time. Makes Riley roll her eyes at me. Okay. The theorem says if you have a polynomial with integer coefficients and you have a 0, then P, where you can have P over Q, basically P over Q is going to be a possible factor. Okay? P is the factor of your A to the 0, which basically is your constant. Okay? Q is a factor of the A to the M, which is basically your leading coefficient. Okay? Alright, so looking at 2x cubed minus 4x squared minus 6. Alright, P is my constant, so that's going to be negative 6. And Q is my leading coefficient, so that's going to be 2. Okay? Alright, so I find the factors of negative 6, which could be positive negative 1 and positive negative 6. Would you agree with that? What other factors do I have of negative 6? 2 and 3. So I could have plus or minus 2 or positive negative 3. And then I do the same thing with Q. My factors of positive 2 is going to be plus or minus 1 and plus or minus 2. Good? Alright, this is the putsy part. P over Q. You list all possible combinations. So, if I start at 1, I'm going to have plus or minus 1 over 1, plus or minus 1 over 2. Agree with that? Then I move down to 6. And I have plus or minus 6 over 1 and plus or minus 6 over 2. Everybody with me on this? Because these are all my P's and those are the Q's, and so I'm making P over Q. You with me? All right, now let's move to 2. So I have plus or minus 2 over 1 and plus or minus 2 over 2. And then I have my last one of plus or minus 3 over 1 or plus or minus 3 over 2. Good? All right, so if you simplify and look at it, we have plus or minus 1. I have plus or minus 1/2. I have plus or minus 6. I have plus or minus 6 divided by 2 gives me 3. I have plus or minus 2. 2 over 2 is 1. I already have that one. 3 over 1 is 3. I already have that one. And so plus or minus 3/2. Okay? So what does this tell us? We have 1, 2, 3, 4, 5, 6. We have the positives and the negatives. So that means I have 12 possible choices for the rational zero. Your zeros will be one of those. You just got 12 choices. So you've narrowed it from infinity down to 12 choices. That makes it worthwhile. Right? So, he's shaking his head at me. Let's use it. All righty. Okay, so here we go. How many roots am I going to have? Let's think about what we know. How many roots am I going to have? 3. Awesome. Okay. Let's think about our signs. Okay. I have a positive. I have a negative. I have a positive. So that means I'm going to have 2 or 0 positives. Okay? Now, if I put negative in, that's going to make this negative, that's negative, and that's negative. So that means I'm going to have 3 or 1 negative signs. Just for when we have that list of P's and Q's, it's going to help me kind of figure out a little bit more. Okay? Alrighty, so here we go. My P is -1, and my Q is 3. So my factors of -1, that's easy. It's just plus or minus 1. Okay? And then my factors of Q are going to be plus or minus 1 or plus or minus 3. So this one's not going to be nearly as ugly. Okay? So that means my P over Q choices are plus or minus 1 and plus or minus 1/3. Good so far? Alrighty. So, here's the putsy part. You use synthetic You just pick one of those. You want to do 1, you want to do -1, you want to do positive 1/3, negative 1/3. And since you have 2 positives or 3 or 1 negative, you kind of just guess and check. What I do is I say, okay, I have 3, -1, 3, -1. Because I'm going to use synthetic division. And in synthetic division, remember yesterday, the remainder theorem said if we get a remainder of 0 down here, then it's a root, it's a factor, right? Okay, so what numbers of 1 or 1/3 is going to probably get me to back to 1 to get me to 0? How about 1/3? Because 1/3 times 3 gets me 1. -1 plus 1 gets me to 0. 0 times 1/3 is 0. So 3 comes down, which gets me back to 1, and I have that remainder of 0. So it's one of those where you have to kind of look at your numbers and think, what number is likely to get it to cancel out? So, okay. All right, so that means that since x is equal to 1/3, I have a root of x minus 1/3. Or a factor, I'm sorry. All right. Then, the nice part about the synthetic is that this means that I'm now, since I started at x cubed and I divided out an x, that means I now am at x squared. I don't have an x, and I'm at a positive 3.
So what if there was a number? What 0 was?
Then it would just be minus 2x or whatever.
Where did you put that at? It'd be 3x squared. And
I have 0x, and then I have a positive 3.
oh, so
Yo.
what if there was like a 2?
Okay, because this part's what's left over.
Yeah.
Okay, so since I started at x cubed, and I basically divided out 1x, that leaves me with x squared, and then x, and then the 0. Does that make sense? And so now there's my factored equations. Do one more. All right. P's negative 22. Q's 1.
Why can't we just factor
Factor it
it like normal?
like normal. How are you going to factor that one?
I don't know. Trying to do all this.
Well, this is because this is it's an. There's a reason why we do it for the next step of what we're doing tomorrow. It's not just about the factoring. That's just the end result for today. All right. So my factors of negative 22 are going to be plus or minus 1, plus or minus 22, plus or minus 2, and plus or minus 11. Luckily, since I just have a plus or minus 1, my P over Q is just the 1, 22, 2, and 11. Okay? All right, so 1, 10, negative 13, negative 22. What number do you think is going to get me to 0 down here? 1, 2, 11, or 22? Think about it. Start off with 1 and 1. That's going to be 1. That's 11. That's 11. That's negative 2. That's not going to work. If I look at my signs, I'm going to have,
11.
you want to do 11?
Maybe.
All right, so that's 11. That's 21. What's 11 times 21?
It's over on.
It's like 203.
Yeah, am I going to get to 0?
No.
Yeah, no, we don't like that one. All right.
It's gotta be 2.
How about, let's try a negative number. Negative 2. So, negative 2 and 8, or 10 gives me 8. Negative 2 times 8 gives me, oh, yeah, negative 16. Am I going to get here? No. All right, 1, 10, negative 13, negative 22. Let's try positive 2. There's 12. 12 times 2 is 24. Hey. There we go. All right, so that means that I have 1 at x minus 2. And then what am I left with here? Because I started as an x cubed, that leaves me as an x squared plus 12x plus 11. Do you agree with that part? Okay, can I factor this? What factors of 11 equal 12? 1 and 11, right? So x minus 2, x plus 11, x plus 1 gives me my final roots.
Wait, why did you change x squared?
Because basically in the synthetic division, it's like saying x minus 2 into x cubed plus 10x squared minus 13x minus 22, right? So I would, how many x's are going to give me x squared? X squared. And then I'd have x cubed minus 2x squared. So synthetic is just this bottom number here is what you would go up on top. So you just put your x's back in. Like you took the x's out to start with, you put the x's back in. And it's always less 1 because you divided 1 out. Does that make sense?